Hi, I'm Kozo. These slides and speaker notes were created by me, but Amazon Polymathy will automatically read it. In this talk, I will show that automation of biological network visualization can be achieved by leveraging Jupyter Notebook. This is the outline of this talk. First, I give you an overview of biological network visualization. Next, I will explain why it would be nice to automate the visualization with Jupyter Notebook. Next, I will show you a demo of automation using Jupyter Notebook. Finally, I will explain what is lacking in this Jupyter Notebook application and tell you the future prospects of it. This table is an example data for a network nodes. A row represents a biomolecule node and a column represents some attribute information of a biomolecule. In addition to the node data, there is also edge data that represents their relationships. Biological network visualization is to create a network diagram like the figure on the right, from the data on the left. In the network figure, visual effects are given according to the cell values in the table. And some biological knowledge can be obtained from the network visualization. Siteescape is the most commonly used software for biological network visualization. Siteescape is a desktop application that imports and visualizes the data described in the previous slide. Siteescape is written in Java, and runs on Windows, Mac OS, and Linux. Siteescape is a popular software, but Siteescape itself is not enough for the real-world workflow. In order to create Siteescape input data, it is necessary to acquire data from multiple data sources, and perform pre-processing outside Siteescape. Since Siteescape is a desktop application, we need to perform some manual operation with a graphical user interface. We may also do some analysis after loading the data into Siteescape. Siteescape has some analytic capabilities, but that may not be enough. After manually manipulating the functions that Siteescape does not have, we can finally obtain publishing quality images. In fact, Siteescape has a mechanism like a Google Chrome extension, to supplement the features that Siteescape does not have. It's called the Siteescape app. The scope of its functionality is not necessarily in this red frame, but the app makes it easy to perform some workflow, with features that Siteescape does not have. The Siteescape app, like Siteescape, must be implemented in Java. However, there are still issues with the Siteescape app. First of all, it's difficult to implement. The Siteescape app must be implemented in Java, but Java is not the primary language for bioresearchers. The primary language for bioresearchers is Python or R. Second, there are few Siteescape apps that will run the entire workflow. For this reason, some manual work is required after all. This is a problem in terms of research reproducibility. So I use Jupyter Notebook and Python or R to promote Siteescape workflow automation. Siteescape is a desktop application, but it also becomes a REST server as soon as it starts. By sending REST requests, we can programmatically perform Siteescape operations that would normally be done in the graphical user interface. By utilizing this mechanism, the workflow can be executed automatically in Python or R. Python and R wrappers for the REST requests are released as packages called Py4 Siteescape and RSci3, respectively. I'm running Py4 Siteescape or RSci3 on Jupyter Notebook to improve the workflow reproducibility. Here I show you a basic data visualization notebook as a demo of automation. You can reproduce this demo with this notebook and Siteescape. First launch Siteescape and then open the notebook in Jupyter. This notebook imports a protein-protein interaction network. And gives visual effects according to the quantitative value. In addition, the notebook experiments with different network layouts. And select protein nodes with quantitative values above a certain value. And finally expand the selection with the Select First Neighbors function. You might think that this automation is too easy to use. However, the Siteescape app and complex workflows are, actually a collection of these basic operations. Getting in the habit of automating usual workflows, with each Jupyter Notebook, not only improves the reproducibility of your research, but also gives you ideas for packaging new feature modules. I showed an example and good points of automation with Jupyter Notebook and Siteescape. In fact, the combination of Jupyter and Siteescape is not always a good thing. There are some Siteescape features that are not yet provided by the REST API, and the environmental setup is a bit difficult for beginners. There are several ways to set up a combination of Jupyter and Siteescape. One is to install everything in a local environment. This is a bit difficult for users, as I mentioned before. The next one is to install everything in a remote environment. This is also a bit problematic. This is because Siteescape does not have a headless mode, and requires the setup of a virtual desktop service in a remote environment. So a moderate type has been developed by Barry Demchik. The figure on the right shows the combination of remote Jupyter and local Siteescape. This is called Jupyter Bridge. It is difficult to open the REST server of a desktop application to the public, and allow access to it from the outside. So the Jupyter Bridge replaced the instructions of the Pi4 Siteescape REST request from remote environment, to a request from a local web browser. By using the Jupyter Bridge, we can control the local Siteescape from Google Colab or Binder as follows. Is the remote Google Colab. On the right is the local Siteescape. Jupyter Bridge runs in this cell. After running Jupyter Bridge, we can communicate with the local Siteescape from the remote Google Colab in this way. So far, I've been working with Siteescape outside of Jupyter. But ideally, we should work with Siteescape not only outside of Jupyter Notebook, but inside of it. Because there are some Siteescape features that are not yet provided by the REST API. To achieve this, I would like to refer to a project called Slicer Jupyter. Slicer Jupyter is a collection of Jupyter kernel and widgets for 3D Slicer. 3D Slicer is a software for visualization and medical image computing. 3D Slicer is a cross-platform desktop application written in C++. With Slicer Jupyter, we can not only automate the operation of Slicer in Jupyter, but also we can operate Slicer interactively in Jupyter. I think that Siteescape can use the same approach as 3D Slicer to strengthen its collaboration with Jupyter. Here's a summary of what I want to convey. Jupyter can be used to complement desktop application for biological network visualization. It's important for the research reproducibility. And Jupyter can be used to replace what was previously done in Java with Python or R. This is important for rapid research and development. There are multiple local and remote software combinations for working with Jupyter Notebook and desktop application. There is precedent to follow. Slicer 3D project is developing kernel and widgets for their desktop application to improve the Jupyter Notebook environment. I would like to thank these people. This automation project is supported by Google's Season of Docs last year. In fact, at first Siteescape automation was more advanced in R than Python. Alex and Christina helped with the Season of Docs work at R. Barry has developed the Py4 Cytoscape, Jupyter Bridge, and the early Siteescape REST API. Py4 Cytoscape is a port of R Sci3's API to Python, so that it can be used with exactly same usability. So I ported what I did first in R, to Python. Jorge developed Py2 Siteescape. It's the predecessor of Py4 Cytoscape. Kay also developed the Siteescape REST API and Py2 Siteescape. I would like to thank Jupyter and those who provide the notebook service, Collab and Binder. I would also like to thank PyData. I organize PyData in Osaka, Japan, and I got Slicer's information from the PyData network. Please refer these papers for more information on Siteescape automation. I would like to thank you all for your attention today.